Okay, hi, Assalamualaikum. Welcome back to Dynamics ECS 429. So today we are going to discuss on this problem, which is a problem related to Newton's second law. Okay, so the sample problem is number 12.7. It is provided in your textbook beer, page 738. So before we begin with this question, I would like you to close your textbook. Please do not look at the solution and let's try to solve this question together. Number one, determine the rated speed of a highway curve. So this highway curve with a radius of 120 meters. So radius dia ialah phi back through an angle. Okay, dia punya angle theta is 18 degrees at which a car should travel to have no lateral friction force. So there is no lateral friction force exerted on it. Okay. All right. Okay. Now, so how do we solve this question? Okay. Number one, what is the question? Determine the rated speed. So the question is, it wants the velocity. Now, what information we have? We have the angle. We have the phi. What else we have? We know the friction is 0. We know the friction is 0. Okay, so because there's no friction, so it's 0. Okay, what else we have? Okay, that's the only thing we have. So how do we want to solve this problem? Okay, now, so basically this problem, if we read carefully, determine the speed of a highway curve. So let's assume there is a highway curve. Okay, so we have a highway, but it's curve. Okay, it's curve, and then the highway curve is not only curve, it has an angle. Okay, the angle back is 18 degrees. So what is the rated speed of the highway? So this question, it wants to know what is the speed of the highway when the angle is 18 degrees and the highway is curved, and it has a radius of 120 meters. So for this question, it did not mention a car or a bicycle or a bike, but let's assume that a car is positioned on the highway curve. So here is a picture of the car banked on a highway curve of 18 degrees. So now the question, what is the velocity? Okay, now, okay, oh, the other information that we have rho 120 meters. Now, for this question, first of all, the question asked is for us to find the velocity. But information that we have is we know theta, we know rho. So for this question, what method are we going to use to solve this problem? What I mean is, what is the best coordinate system to use? Remember, I have taught you three. Can someone answer me? Hello? Remember, for Newton's second law, there are three coordinate system methods that you can use. Okay, let me remind you again. What is it?
It's a
Number one is
transverse.
okay, rectangular coordinate system. Number
Rectangular
Rectangular.
and
two
non-rectangular, is it?
is
Normal and
normal and
tangential.
transverse. Number
Radial and
three is
transverse.
radial
And transverse.
and transverse. Okay, now those are the three coordinate system. But right now I'm asking you which one.
Radial and
Radial
transverse.
and transverse.
Oh, wrong answer. It's
Normal.
Normal and tangential.
normal and
Sure.
tangential. Okay.
Oh.
Why? Because it gives the
Other
value of rho,
radius.
and
Yeah.
because it is moving on a curved highway. So
Yeah.
let's assume uh hold on. Let's assume we have a curved highway here. This is the pandangan dari atas. Okay, picture this is from the view from the top. So this is your car. Okay, so this car is moving on a curved highway, and it has a, from normal, it has a rho equals to 120 meters. So this
meter.
is the radius. Okay, now what it wants you to find is the, is what? The
Velocity.
Velocity.
velocity. And we know velocity is tangent to the path.
Let's see to the
Okay,
past.
so now, now it wants you to find the velocity. Now, because we know this is normal and tangential, what is the formula for velocity? We know acceleration equals to
N equals to v square over
v
rho.
squared over
Rho.
rho. Okay, so we need to find what is v, but we have rho, but we need to find what is,
A. A.
we need to find a. So when we need to find a, what it means is, to find a, we need to use the formula Newton second
Second
law,
law.
which is F equals to
MA.
ma. So we need to find ma first. Now, so for this question, we need to draw the free body diagram and also the kinetic diagram. So how do we draw the free body diagram? So number one, for this question, the free body diagram, we will have the weight. The weight will be at the center. It will point vertically downwards. This will be the weight. Weight equals to mg. What else you have? You will have the normal force also. Normal force equals to N. Okay. How about the friction? Do you have the friction? No,
No.
because the friction is zero. Okay. So this is the free body diagram. Okay. Next, we need to draw the kinetic diagram, because the acceleration is in uniform circular motion, so it is pointing exactly at the point here. So this will be the acceleration m a n. So now we have to use the coordinate system, which is the normal and tangential. So let's say we have this will be our y direction, this will be our x direction. Okay, now, so now we're going to use the, oops, where is it gone to? Now we're going to use the formula of Newton's second law using this. So we have summation forces. What do you have? You have F y equals to max. We also have F y equals to, fx equals to max. Okay, now, so for this question here, now, when it is, I want to ask you, if we have a vehicle like this, okay, you look at my picture on the screen. Let's say we have a vehicle here. This vehicle is going on a straight line and the velocity is constant. What is the acceleration value?
0.
Okay, only one person is answering. Okay, yes, the answer is correct, is 0. So when you have a vehicle moving along a straight line and the velocity is constant, the acceleration will be 0. But when you have a vehicle moving along a curved line, the same vehicle moving along a curved line, what will be the acceleration? Hello? The acceleration will not be 0. Understand? If you have a vehicle moving along a curved line with constant velocity, the acceleration will not be 0. But if you have a vehicle moving along a straight line and the velocity is constant, the acceleration is 0. Okay, you understand? So
Yes.
we have a value of acceleration. Okay, now I want you to write down the equation for Fy and Fx, but make sure you need to resolve. Now, your weight here is already in the direction of y. So what you need to do, you need to resolve your n. You
Yep.
need to resolve your n in y direction and your x in Your n in x direction. Okay, now let's write down this together.
Madam,
Yeah,
kenapa yang axis y-x tu tak ikut plane yang incline tu?
because because your an is in the same direction as the normal force. It must be the radius from it must be the normal force. Must be perpendicular. Your t is the direction of the velocity. Right now, ini gambar bontot kereta. Now this is your car kan? Car kan? Your car is moving like this kan? So your velocity is here. So your acceleration must be perpendicular, must be 90 degrees, understand? So it must follow that straight line. Okay? All right. Okay. So now I need you to write down the equation for Fy and for Fx. So for Fy, what do you get? You get n cos theta or sin theta? N,
Cos.
yes, good, cos theta. And cos
Cos.
theta minus W equals to what?
0.
MKY.
Equals to 0.
0.
Okay, that's correct. So the second equation, n
Sin
sine theta equals to m
MAM.
a
MA.
n. Okay, so here you have two equations already, right? How are you going to get how are you going to get a? Can you please find me a? Okay. Now, in order for you to find the velocity, you need to use equation number 2, right? N sine theta equals to MAN. So N sine theta equals to M. What will be your A? V squared over rho. Okay, now you have the value of rho. Okay, you need to find V, but you do not have M or you do not have N. But you know N also equals to the weight over cos theta. Am I right? You have this equation. But if you put this equation into here, one equation is in terms of W, the other equation is in terms of M. So you need to simplify this. And what do you know? You know W equals to
MG.
MG.
So to simplify this, you either can make W as the main form of value, or you want to make M. So let's say you make M. M will be equal to W over G. So you replace M, this M, you replace this M with W over G, and this N will be W over cos theta. Everything will be in the symbol W over W. Am I right? All will be in the same symbol. And then you can solve the problem. So let's put N as W over cos theta multiplied by sine theta. M replaced by W over G. V squared over rho. So can you find me what is V? What will V be? Okay, masih ada yang baru nak masuk. Okay. So can you quickly find me what is V? Dah? So what is the answer for V?
19.6 meter per second.
Yes, 19.56. Okay, you're not looking at your textbook, eh? You're
No.
answering this question yourself, eh? Good.
Yes.
So V will be 19.56 meter per second. All right. Okay. Now, so when the question they ask you to find the rated speed, you need to convert it to kilometers per hour. Can you please convert it? What would you get? When you convert it to kilometers per hour, it will be 17.4 kilometers per hour. Okay, now, so what happens when you increase your theta? What happens to the results of the velocity? When the angle theta
Increase.
increase, what happens to the velocity?
Velocity increase.
Increase.
The velocity increase. So basically, pernah tengok tak pertandingan tu yang diorang naik basikal yang pusing-pusing tu? Yang laju-laju tu. Apa nama tu?
Velodrome.
So lagi apa? Lagi apa? Angle dia lebih besar, lagi laju lah. You understand? So itu yang you boleh pusing. Okay, alright. Okay, good. Now, understand this, okay? You understand this question, how to solve? So there are many questions that is related to normal and tangential that you can try to use and solve the problem, okay? So there's a lot of tutorials I want you to try, and I'm sure you can solve the problem, okay? All right, make sure your drawing is correct. Your normal, your tangent, 90 degrees, your rho, okay? Everything. Okay, now can we proceed to our next question?
Yes.
Okay, so our
Yes,
next
madam.
question is this question here. Okay, now I'll read you the question. So this time we have two blocks. Okay, bukan block there. Ni ialah two blocks. Okay, P and Q. Okay, now let's assume this is block P. This car is block P, and this car is block Q. Okay. Okay, yang macam Formula One ni yang adalah Q. Yang ini adalah P. Okay, so we have two blocks P and Q. Okay, alright. So two blocks P and Q. Okay, so this is block Q, and yang depan ni adalah block P. Okay, now what happens to the block? Let me read the question. Okay. So we have two blocks P and Q. Okay, they are held stationary apart. Okay, they are held stationary apart. How many meters apart? 15 meters apart on an inclined plane, which is 30 degrees. Okay, and the kinetic of coefficient of friction between P is 0.3. So dia punya friction surface ni for P 0.3, and dia punya friction surface for Q adalah 0.1. Now, so these blocks are positioned like this. So at first they are at rest, and then they are released simultaneously. So what will happen? What do you think? Because their punya friction is different, right?
Yes.
Friction for this Formula One car is 0.1.
0.1.
This one is 0.3. Now, when you have a friction that is smaller, what do you think happened to the car?
Melanggar. Lagi
Yes,
laju.
this car will collide with that car.
Collide.
At first, they're going together 50 meters apart, but because this car, this Formula One car, this Q has a smaller kinetic coefficient friction, what will happen? It will go faster, and at one certain point, it will collide with that car. Okay, both are 50 meters apart, but at a certain moment, this goes faster, bang. Understand? Okay.
Yes.
So now, what is
Yeah.
the question? What are we trying to solve now in this question? So for this question, it wants the
Time taken
Time
and distance.
and distance. Okay, now T and S. Now, when you get this question, obviously the first thing you think mesti you ingat Newton's second law, rectangular coordinate system, right? Am I right? Now, T and S is not in the formula of Newton's second law. So, macam mana you want to solve it?
Kinematic.
Mind mapping?
Kinematic.
Yes, kinematics. So you need to write the basic kinematic equations. Can you write for me the basic kinematic equations? What is it? V equals to V naught ACT. And then you have
S
S equals
to
to S
S
naught
naught
plus
plus V naught T
yes,
plus 1/2 AC T squared.
yes, one more.
V squared equal to V naught squared plus 2AC minus a bracket S minus S naught.
Okay, good. So you have these three equations. Now, the thing is, the question, you need to find T and S. So in order to do that, you need to use equation number 2. Okay, so you have equation number 1, equation number 2, and equation number 3. So the correct equation that you need to use is equation number 2. Okay, because equation number 2, you have S and you also have T. Am I right? But do
Yeah.
you have the acceleration? What is the acceleration? What is the acceleration of block P and Q? Do you have that?
Yes,
No.
0. Is it?
0?
Ah,
Why 0? Now, it is not moving with a constant velocity because it has different friction value. Okay? All right? Okay. This question, it did not mention that it is moving in a constant velocity. So it does have an acceleration, but acceleration for P and Q is different. So what you need to do, you need to use the Newton's second law formula, which is F equals to ma, and find what is the acceleration for block P and what is the acceleration for block Q. Okay? All right. Now, let's find the acceleration of block A and acceleration of block let's find the acceleration of block P and Q using formula F equals to ma, which is the formula of Newton's second law. So for this question, we need to establish a correct coordinate system. Okay, now, so let's assume our coordinate system, this is X, this is Y. Okay, now, you need to draw first what? The free body diagram. Can you draw me the free body diagram? First, you have the free body diagram. You have the weight going down. And then you have the normal force in the direction of Y. Okay, so what you need to do, you also have the friction. Okay, since these blocks are moving, in going down the hill, the friction must be in the
Up.
opposite direction. Okay, so it will be mu kn. So the friction is different for both. Okay, understand? Okay, now don't forget you need to resolve W, right? Okay, hold on. You need to resolve W because W is not in the direction of X and Y. So this is in the same direction, N is in Y direction. Okay, so you need to resolve W. So W is here. So you need to resolve in Y direction and in X direction. So what is number 1 and what is number 2 when you resolve? Can you tell me? Number 1 will be what? When you resolve W. Number 1 will be W sine theta or W cos theta?
Fine.
Sign.
Yes, W sine
Sine.
theta. This one will be W
Sine
cos. Number 2 will be W
cos
cos
theta.
theta. Okay, good. All right.
Theta.
Here you have only drawn the free body diagram. You also need to draw the
Kinetic diagram.
yes.
Eh.
Please draw the kinetic diagrams. Okay. Now for the kinetic diagram, which is the direction of MA? Is it number 1 or is it number 2?
Number 2.
Why number 2?
Number 2.
Why?
Number 2.
Why number
That's
2?
where the
normal.
force go in.
Opposite the
Yes,
Because it's
kinetic.
because it's the
opposite the
direction.
friction.
That yes, it's the same direction as the acceleration.
Moment.
Okay, right. Now, let's now write now. So our task now is that we need to find the acceleration of AP and AQ. And what we do, we need to import it in the equation number 2 here, this kinematic equation. Okay, and then we can find what is S and what is our T. Okay, so can you please quickly find for me the acceleration? Okay, so we can do this together, but if you are fast, please proceed. So we have summation Fy equals to MAY, and we also have summation Fx equals to MAX. So what is Fy? We have the normal force minus W cos theta equals to what?
0.
Yes, good. Equals to 0. Okay. Then we also have W sine theta. For Fx, we have W sine theta minus mu k and equals to MAX. Okay. So now we simplify this. We write what is N. So we will get W cos theta. And then we put equation 1 into equation 2, and then we can find what is A. So can you please find me what is A? So if you put equation 1 into 2, you can simplify the answer. So I will quickly do this because I don't want to waste time. We will get acceleration equals to G multiplied by sine theta minus mu k cos theta. Okay, why is there is a G? Because what I did is W equals to mg. I replaced M equals to W over G.
G.
Okay, all right. Now, so what would you get for the acceleration for block P? So acceleration for block P, can you quickly calculate for me? What would you get? Acceleration for block Q. So if you quickly calculate acceleration for block P equals to 2.35 meter per second squared, and acceleration for block Q will equals to 4.05 meter per second squared. Did you get this answer same as me? I hope so. Okay, now what you got it? Good. Okay, now what can you see here? We notice that our acceleration for block Q is bigger than our acceleration for block P. What does that mean? It means the acceleration of this Formula One car, which is block Q, will eventually collide with car P. Why? Because it is faster, right? So in the end, the two blocks will collide. Yes, good. Collide tu langgar lah. Okay, now we have the acceleration. How are we going to find the distance between each block? Now, obviously, you have these two cars. Okay. Block P will always be 15 meters apart from block Q, but block Q is going faster. Am I right? So we need to write down the important information that we have in order to solve this question. So it means the position S for block P and Q will be different because Q moves faster than P. So Q punya distance will be, because it's faster at a certain time, kan? At the same time, since Q is faster than P, Q will reach can achieve a faster length position. Do you understand? Kalau
Yes.
don't understand, kenalah cari kereta mainan ni buat dan main-main kat rumah to understand. Siapa yang ada adik kecil lagi lah. Okay, now, so let's write down the parameters we have here. So we have block P and we have block Q. Okay, what do we know of block P and block Q? Okay, we know the initial position is 0, right? Because it start from rest and it is released simultaneously, kan? So we know that V naught also both will start with 0.
0.
Okay, good. Now, okay. Next, we know that we need to find the S for each of the blocks. The position, we know the acceleration value already. We know the acceleration for block P and Q. Okay. And we need to find S and T. So S and T will be the same, but our S value will not be the same. Okay, S for P and S for Q will be different. Okay, so now, so let's assume, so our S for Q will be 15 meters plus X. Our S for P will be X. Okay, right? Because it will be always 50 meters apart, but P is still moving, right? But Q is moving faster. So this is the values that we know. Okay, now, so basically, what have we decided? Which kinematic equation we're going to use?
Second one.
The second one. Okay, now, so let's write the second equation down. So we have S equals to S naught plus V naught T plus 1 over 2 ACT squared. Okay. So for block P, our S will be X. This one will be 0. So we are left with 1 over 2. Our acceleration is 2.35 find T. So again,
Madam,
for this one, it will be X plus 15 equals to 0 plus 1 over 2 4.05 T squared. Okay, so now you have these two equations. What can you do? You can solve it simultaneously and find the answer. So can you please calculate quickly for me what is the answer? So if you calculate quickly, you get what is X. So X is 20.73 meters and the time T is equal to 4.2 seconds. So this is the answer. Okay. Right. Okay. So what you learn here today, when you are solving a question or a problem that is related to Newton's second law, it doesn't mean that you're only considering F equals to ma, Fx equals to ma. Sometimes you have to relate to chapters before or chapters after. It can be a combination of two chapters to solve one problem. Understand? Okay, and the key thing in order to do this is read the question. What does it want? Oh, this question, it wants the position and time. But I know this method, you need to use Newton's second law to find the acceleration. Okay, understand? Okay, now, are you ready for the next question? Are you okay here? Is everybody fine?
Yes.
Huh? Is it too
Yes,
much?
madam.
Okay. All right. Please do not worry too much. This video is already recorded. I will share the link at Facebook because I know when you open a video at Facebook, it doesn't use your data because Facebook has made video free. Free. It doesn't use your data. So you can look at the video at Facebook. Okay? All right. Now, Facebook ECS 429 for those that have not registered. Okay. Now let's do the second example. Okay, now this is an example. Okay, now. So here we have the second example. Okay, now. Okay, are you ready? Okay, now I will read the question. As the hydraulic cylinder rotates around O, so we have a hydraulic cylinder. It is rotating about point O. So let's say this is our hydraulic cylinder. Okay. So we have this okay, macam mana nak buat ni? Okay. 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 Okay, anggaplah ini point O tu So we have a hydraulic cylinder that rotates about point O, so dia rotate, and it is exposed length L of the piston rod P is controlled by the action of an oil pressure in the cylinder. So if the cylinder rotates at a constant rate, so this cylinder dia rotate at a constant rate theta equals to 60 degrees per second, and then the L is decreasing. So this is the L, so it's decreasing. Dia makin, maksudnya dia dekat atas ni, dia makin masuk ke dalam, ke point O. Point O kat sini. Okay. So it is decreasing at a constant rate of 150 millimeters per second. Calculate the magnitude of the velocity and the acceleration. So for this question, dia nak the velocity and the acceleration. Okay. Dia nak the velocity and the acceleration when this thing reaches L equals to 125 mm. Understand? Okay, now. So this question is a bit tough to understand, but I try my best to explain to you. So please stay calm, stay cool. So number one, what coordinate system you want to use to solve the magnitude of velocity and acceleration for this question? Can anyone tell me?
Radial transverse.
Yes, obviously you need to use radial and transverse. So how do you decide when you want to use radial and transverse? You can use radial and transverse when a particle is fixed at a point and moves along a rotating arm. So we can say the particle is fixed about a point, but it is moving along a rotating arm. So we can assume this is as the rotating arm lah, this part here lah. Okay, so number one. Okay, let's write down the step together. Yeah. So apa? Okay. Kat sana hujan lebat ke? It's raining very heavily here. I hope hujan I hope apa?
Madam.
Ya ke? Tak apa kita try. Kadang-kadang hujan lebat macam ni apa? Internet trip. Okay. First, you need to set up your coordinate. Ya Allah, tulisan. First, you need to set up your coordinate system. So we have set up, we are going to use radial and transverse. Okay. Next, our next set, we need to put in the diagram our R and theta direction. Okay. Okay, what is our R direction? Where is our R and theta direction? So our R direction is this one here. What is the direction of the R? The direction of the R is the direction of the extension and contraction. Okay, dia extend, dia boleh contract. Dia extend, dia boleh contract. That is our direction of R. And in this case is the direction of the beam, for example. Okay, dia boleh extend, dia boleh contract. That is R. Okay, so we have established the direction of R. How about the direction of theta? How do we establish this direction of theta? Okay, theta is the direction 90 degrees of the arm. So let's say this is our arm here. Our theta should be 90 degrees of the beam. So this is our arm, the beam of our arm. So theta should be 90 degrees. Okay, so we have established that. Okay, now next we need to write the variables. Okay, next we need to write the variables that is going to go into the velocity and acceleration expression. We need to write the variables that is going to be in the velocity formula and the acceleration formula. Okay, using the radial and transverse. Okay, so what are the variables that we have. So we have theta, we have theta dot, and we have theta double dot. Okay, and we also have r, we have r theta, and we also have r double dot. Okay, can anyone tell me what is theta dot means? What is theta? Theta is the
Angle.
okay. What is theta dot?
A differential angle.
Yes, theta dot
Velocity.
is the derivative
Angular
of the
velocity.
angle. So theta dot is the derivative of the angle, or we call it angular
Velocity.
velocity. Okay, and what is theta double dot? Theta
Angular
double dot is
acceleration.
the second
Angular.
derivative, or we
Yes.
call it angular
Angular acceleration.
Acceleration.
acceleration. Yes, good. Okay, you know. So similar with r, r, and then we have r dot, and then we have r double dot. Okay, now, so let's write down what information we have based on this question. What information we have? Okay, so basically we have theta, we have the constant rate. You mentioned here constant rate is 60 degrees per second. So when is the what constant rate mean is the speed, is the velocity. So constant rate is theta dot, it means it is 60 degrees per second. And what is theta? So theta is 60 degrees. So what is theta double dot? Can anyone tell me what is theta double dot?
60 degree per second.
No, theta double dot is 0. Why? Because it says
Integrate.
theta
Differentiate.
dot is constant rate, 60 degrees per second. So when the velocity is constant, what happens to the acceleration? So acceleration becomes
Zero.
Zero.
zero. So theta double dot is equals to 0. Okay. So since again it has a constant velocity, we will have acceleration equals to 0. So theta double dot equals to 0. Okay. So this is our theta value. Now how about our other value? Next, we need to relate with the length. Okay, what is the length we have? So the length is 125 mm. And what is the constant rate of the length? The
Velocity.
constant rate of the length is
Velocity.
150 mm per second. But here it mentioned it is decreasing. So it will be negative 150 millimeters per second. And this one is L dot. How about L double dot? What is L double dot?
0.
Yes, good job. L double dot is 0. Now, so we have theta. So we have the value of theta. That's fine. But our length is in terms, we need to convert this into R. Okay. So how do we convert this into R dot and double dot? Okay. We need to convert the length in terms of R dot and double dot. Do you know how to do that? Okay. Okay. Are we okay here? Are you progressing?
Yes.
Yes.
Okay. Now we need to convert our length into R dot and R double dot. Okay. Now, what is R? Okay. As you can see, R is from here, from 0 until the end here. So what we can say is, let me use another color. R equals to 375 plus L equals to R. So what is our R? What will we get? Our L is 125 mm. Our R is 375 plus L. So what is our R?
500.
Pardon?
500.
Yeah, good. 500 mm. Okay, now. So that is our R, 500 mm. So L dot equals to negative 150 millimeter per second. So this will be the same. This will be our r dot. And what will be our r double dot?
0.
Yes, our r double dot will be 0. Good job. So now we need to write down the equation for velocity and acceleration. Okay, we need to write this equation down. So what is the formula for velocity? Velocity equals to r dot
Square.
r dot. Okay, in terms of in the vector coordinates. Okay, it means the vector coordinates plus r theta dot in the L direction, vector L theta, vector L. Okay, so this is our equation. So what is r dot? Okay, our r dot is negative 150. Okay, what is our r? 500. What is our theta dot? What is theta dot? 60 degrees per second. Hello, what is our theta dot? Can someone answer?
60 degree per
Per
second.
second. But you need to convert this to radian. So what do?
Oh yeah.
60 multiplied by pi divided by
180.
180. Okay. So multiply by 60 divided by 180. Okay. So what will you get? You will get negative 150 in the vector of ER. Ni ER dengan L naught ni macam XI dot YJ KJ. Faham tak? In that direction You remember that? Okay. Plus ni dapat apa? 524 L naught. Okay. Now this one your answer velocity will be in millimeters per second. But now if you go back to the question, what does it want? It wants the magnitude of velocity and acceleration. So it means in order to get the magnitude of the velocity, what do you need to do? You need to square root 150 squared plus 524 squared. So what do you get for the velocity? Can you please quickly calculate for me? Dapat tak? Hello, I hope you are here.
545.
545.05.
Okay, 545. 545 millimeter per second. Okay. So that is the answer for the magnitude of velocity. So next, we need to find the acceleration. Okay. So what is the acceleration formula? Acceleration will equal to r double dot minus r theta dot squared plus r theta double dot plus 2 r theta dot. Okay, now what is our r double dot? Our r double dot. What is our r double dot?
0.
0.
0 minus 500 multiplied by 60 pi over 180. Jangan lupa square. Plus our r here is 500 multiplied by 0 plus 2 multiplied by, oh sorry, lupa sini, r dot. Okay. Multiplied by r dot, which is minus 150, multiplied by theta dot, which is 60 pi over 180. Okay. Alright. Okay. So we need to find this. What we get? So here you get negative 548 minus 314 L naught millimeter per second square. Now, if you want the acceleration magnitude, what do you need to do? Class? You need to? Hello, guys. You need to?
Square.
What? Square root the answer. When you square root the answer, what you get? You get the magnitude of the acceleration, which is equal to 632 millimeter per second squared.
Square.
Okay. All right. Okay. So this is the answer. Okay.
Bukan plus lah, madam.
Huh?
Plus yang 548 square plus 314 square. Yang untuk acceleration.
Ya. Plus. Kat sini negatif. Nanti you square negatif, you dapat apa? Positif balik kan? Okay, thank you. Okay, so basically untuk soalan ni, so if you want to find the magnitude, you need to square root. So for this question, what I want to highlight, what is important is for you to understand how to extract the values and the parameters and how to sketch when you are dealing with question for related to radial and transverse. Okay, this is only just a small part of it. Okay, what I need you to do is just try to understand this first. Later, I will give you more questions that are related that uses the Newton's second law. Okay. All right, but at least you understand that when you get the question, number one, you need to set up your coordinate system. So you have chosen, you need to use radial and transverse. Number two, you need to draw the axis, the radial and transverse axis, the R and theta direction. And number three, from the question, whatever parameters is given in the question, how you extract that value and how you able to interpret the values given in the question into the equation. Okay, so actually there is more to this radial and transverse. However, I don't think we have enough time today, but what I'll do is I will prepare videos for you, so for you to look, and you have a lot of tutorial questions that you can try, and when you have any problems you can always ask me. Okay, all right. So semua okay? Okay, I'm okay.
Okay.
I hope it's
Okay,
okay.
madam.
I know this is pretty too much today because we're trying 3 tutorial questions non-stop. But as I mentioned, I'm going to share this video link. So if you are stuck anywhere, you can always go back and refer and look at it. Okay. So jangan worry sangat lah. Yang
Okay, madam.
penting you tahu kewujudan ada radial and transverse. You tahu benda tu macam mana, the concept, the fundamental, then you should be fine lah. Okay. Alright. Boleh?
Okay, madam.
Boleh, madam.
Okay, good job. Thank you for all your coming. For coming for this session. I hope you have learned plenty about Newton's second law and how to use the 3 different types of coordinate system. Okay. All right. Thank you so much. And if I have any questions, just give me WhatsApp. Okay. So take care and have stay home and have a nice dinner tonight. Okay.
Thank you, Doctor.
Boleh? So anything before we stop? Anything?
Yes, Doctor.
Ada?
Ada. Minggu ni kita ada quiz ke?
Tak ada.
Oh, quiz tu?
Next week kot.
Oh, okay. Alright.
It's okay, don't worry. Nanti kita akan update when we will have the quiz. Okay?
Alright. Thank
Alright.
you.
Okay, thank you so much. Alright. Take care.
Alright,
Alright.
thank you, madam. Stay
Okay,
safe.
bye.
Assalamualaikum.
Waalaikumsalam.
Thank you, madam.
Thank you, Doctor.
Alright, bye.